3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
On the morning of July the 11th, 2022, the National Aeronautics and Space Administration, or NASA as we know it to be, unveiled the first images captured by the James Webb Space Telescope, or again, JWST, an instrument hailed as the most powerful space telescope in history. Named after NASA's second director, the telescope underwent a 26-year development process. The patience, time, and resources invested by the scientists at NASA into the JWST have been rewarded by the cosmos. The images of distant galaxies captured by the James Webb Telescope are gradually revealing information that challenges our understanding of the universe. Could we become the Galileos of this new era? Join us today as we watch this fascinating video and welcome to Eyes 200M, where we will embark on a journey to explore the mysteries of the universe from the dawn of time. James Webb has discovered 700 galaxies beyond the edge of the Big Bang. The first achievement announced by the James Webb Telescope is the image capturing light from the SMACS 0723 galaxy cluster. This galaxy cluster is located at a distance of 5.12 billion light-years and lies in the southern part of the constellation Pisces. It is a patch of sky visible from the southern hemisphere of Earth and is often visited by the Hubble and other telescopes in search of deep cosmic history. The initial data is of immense significance, as it reveals the structure of the universe when it was just 600 million years old, measuring from the starting point of the Big Bang. Scientists anticipate that the JWST can uncover even more about the formation or demise of stars and planets, the shape of black holes, or the existence of extraterrestrial life. The latest information has somewhat fulfilled humanity's aspirations, as the images of 700 galaxies at the edge of the universe are sent back from James Webb. The evidence captured by infrared light has caused the scientific community to pause and reassess the models of the early universe. Can humanity overcome the shock of this knowledge and construct a new cosmological model based upon these new unimaginable discoveries? That remains an unanswered question. However, we all know that, quote, "Today the ancient hidden part of the universe will reveal itself, and our understanding of the cosmos will forever be changed," said Kenneth Sembach, director of the Space Telescope Science Institute, or TSTSI. So what exactly has the JWST unveiled about the universe? It is precisely the information that humanity has been searching for ages: the genesis of the endless cosmic night with its stars. Among the 700 galaxies within the reach of JWST's observations, astronomers have discovered 6 candidates that could overturn the entire theory of cosmic formation. The entire knowledge that we have built up until now may now be flawed, as the images from JWST reveal galaxies approximately 13.5 billion years old, containing tens of hundreds of billions of stars with masses equivalent to that of the Sun, just 500 to 700 million years after the Big Bang. This means that they are comparable in size to our own Milky Way galaxy. According to a recent study published on February the 22nd in the journal Nature, the newly discovered galaxies are so large that they contradict 99% of the representative models for early galaxies in the universe. This has left scientists utterly perplexed. The current theory suggests that galaxies begin their formation from small stellar dust clouds and gradually grow over time, but new discoveries are proving the opposite. It is, quote, reversing what many believed were well-established scientific theories, Joel Leja, an assistant professor of astronomy and astrophysics at Penn State University and co-author of the research paper, stated. These findings make the entire picture of the galaxy formation as we understand it uncertain. These 6 galaxies are not the oldest ones observed by JWST. Last year, scientists discovered 4 galaxies dating back to approximately 350 million years after the Big Bang, but those galaxies were much smaller in size. Dr. Emma Chapman, an astrophysicist at the University of Nottingham, who was not involved in the latest research, stated that further observations of other discoveries are needed before dismissing the current models of our universe. Currently, the research team is planning to gather spectroscopic images from the data sent back by JWST. This method can provide more accurate information about the age and allow for better estimates of the masses of the 6 new galaxies found. If you're interested in the latest results, please give us a like, subscribe, and turn on the notifications. EYES 200M will keep you updated and analyze the latest information for you. Now, let's delve into the hypothesis derived from the JWST discoveries. Will our understanding of star and galaxy formation change? Well, until now, the process of star and galaxy formation has remained shrouded in mystery. Erica Nelson, an astronomer at the University of Colorado Boulder, states, "Each year the Milky Way produces 1 to 2 new stars. In contrast, some of the 700 objects observed by JWST may generate hundreds of new stars annually and span throughout the history of the universe. If these findings can be verified, we will take a significant step forward in exploring and redefining the universe." End quote. We cannot rule out the possibility that these galaxies could be quasars or supermassive black holes. The new infrared images obtained by JWST will need further clarification on this matter. According to the theory describing the processes following the Big Bang, approximately 1 to 300 million years after the explosion, the first stars began to form. These were very large, bright stars responsible for the ionization process of the universe. At this time, we did not have yet elements heavier than lithium from the nucleosynthesis stage of the Big Bang. The first stars produced heavier elements through stellar nucleosynthesis. Therefore, the majority of the primordial light in the universe may be ultraviolet radiation from these very hot stars. The surface temperature of the stars also began to ionize hydrogen and neutralize helium around the stars after their formation. We refer to this event as the era of reionization. Scientists from the California Institute of Technology and the Sloan Digital Sky Survey have also found evidence for the final stage of this reionization process. They discovered strong absorption of ultraviolet radiation in the spectra of quasars at around 900 million years after the Big Bang. These findings suggest that the remaining neutral hydrogen was ionized at that time. If the stars were indeed very massive, their lifetimes would be very short, only a few million years. Some stars would explode in supernova, releasing the metals they produced. Stars with masses between 100 and 250 times that of the Sun are predicted to be completely destroyed in a powerful explosion. Most of the first stars fall within this mass range. Metals are more efficient than hydrogen in cooling the star-forming clouds and enabling them to collapse into stars. And even a small amount of metal production and release can have a significant impact on star formation. So, what is the contradiction here? If everything happened according to our previous understanding, the reionization process would occur more than 1 billion years after the Big Bang. After that, more stable stars would be formed. It would take billions of years more for galaxies to begin to appear. But now we have mature galaxies with ages as young as 500 to 700 million years old. What has happened to the theory of dark energy and the rate of cosmic expansion? Or are there still other mystery factors about matter and energy that we are yet to discover? Evidence of organic molecules in the early universe. Now, let us revisit the theory of the particle formation process to gather more evidence on how stars and galaxies were formed. According to a study published in the journal Nature in June of 2023, scientists using the JWST have discovered a cloud consisting of complex organic molecules within the galaxy SPT 0418-47, located 12.3 billion light-years away from Earth, and these are the oldest known organic molecules ever identified by humans. The spectroscopic data reveals that these organic molecules belong to complex forms, primarily aromatic polycyclic hydrocarbons, or PAHs for short. On Earth, PAHs are found in forest fire smoke and car exhaust fumes. In space, they may play a significant role in star formation. Scientists speculate that they help regulate the temperature of gas clouds in stellar nurseries, thereby influencing the timing and location of star development. PAHs are considered one of the fundamental building blocks for the longest-lasting forms of life here on Earth. What does this mean? Isn't it fascinating that these organic molecules existed in the early universe just over 1 billion years after the Big Bang? This is something that no cosmological model has ever addressed. Joaquin Vieira, a co-author of the study from the University of Illinois Urbana-Champaign in U.S., stated, quote, "We were very surprised by this discovery. It has provided new insights into the complex chemical interactions occurring in the early galaxies of the primordial universe. The detection of these complex organic molecules at such a distance is a significant breakthrough," end quote. Humanity first became aware of the galaxy SPT 0418-47 in 2020 using the South Pole Telescope of the National Science Foundation. The mass of the stars could only be determined through a physical trick called gravitational lensing. This effect occurs when light from a distant object is curved around a nearby massive object due to its gravitational force. During this process, the distant light is distorted and magnified, and in the case of SPT 0418-47, scientists calculated that it appeared over 30 times brighter. During the analysis of this light, initial findings indicate that SPT 0418-48 contained a significant amount of heavy elements. However, the South Pole Telescope was unable to provide a clear view of its carbon-containing organic components due to inadequate wavelengths. Thanks to the JWST, though, everything is much clearer now. Justin Spilker, an astronomer at Texas A&M University and the lead author of the study, stated, quote, "Everywhere we look, we see molecules associated with forming stars. This supports the hypothesis that organic molecules aid in the birth of stars," end quote. However, what remains puzzling is the uneven distribution of PAH cloud densities. This still remains an unanswered mystery for us all. SPT 0418-47 exhibits several similarities to our own Milky Way galaxy, which is unusual for an ancient galaxy. Galaxies from the early universe are typically thought to have different shapes compared to those observed today. Francesca Rizzo, a researcher at the Max Planck University for Astrophysics in Germany, stated, "This discovery represents a breakthrough in the study of galaxy formation, revealing that the structures we observe in nearby spiral galaxies and in our Milky Way even existed 12 billion years ago," end quote. I cannot express enough how remarkable this finding is. We can utilize these studies to determine the time frame in which the universe and galaxies formed. It is possible that in a distant place, billions of light years away, a civilization similar to Earth was formed and continues to exist today. This is truly awe-inspiring. Conflicts regarding the formation of galaxies. According to our current theories, there are two ways in which galaxies form. The first model asserts that giant elliptical galaxies are formed through the rapid collapse of dark gas and matter. During this process, most of the dust clouds quickly transform into stars. Subsequently, galaxies only undergo slow changes as stars evolve. This scenario is referred to by astronomers as the top-down process. The second model demonstrates that giant elliptical galaxies are primarily formed through the merging of smaller galaxies. They undergo a transformation of their gas content as stars form, following a bottom-up scenario. These observations, when considered together, suggest that the giant elliptical galaxies we observe today are formed through a combination of both top-down and bottom-up mechanisms. In the case of the largest galaxies, formed within the densest matter clusters, both processes occurred early and rapidly in cosmic history. However, both hypotheses for galaxy formation assume that they occurred billions of years after the Big Bang. At that time, the universe was at least 9.8 billion years old, with dark energy causing the expansion rate to be slower and more stable. If the evidence for the earliest galaxies from the James Webb Telescope is accurate, we will have to reconsider our models. It is possible that we will develop new theories about dark matter. But what is evident here is that the expansion rate of the universe could be significantly higher than the speed of light. Despite significant efforts, humanity still does not fully understand the majority of the knowledge related to dark matter and dark energy. This is the greatest variable that affects cosmic research and exploration. To address this issue, NASA and the U.S. Department of Energy plan to establish the Joint Dark Energy Mission, or JDEM, the first program created to study dark energy. However, the JDEM project did not receive funding, which is extremely regrettable. Why and how does dark energy relate to the formation of galaxies? This is a long and complex story. However, if you're interested, please follow and comment and let us know. In addition to providing the latest information from scientific journals, we are also delighted to assist you in exploring other interesting and fascinating areas of astronomy. Thank you for watching this episode today. We look forward to seeing you again in upcoming issues.